guys, I'm standing at the top of a dune called Mount Tom. In the distance you can see Lake Michigan. About 10,000 years ago during the Ice Age, Lake Michigan was actually just a glacier, and the lake that we know today was formed from that glacier when it pulled back and came forward and pulled back and came forward as the climate during the Ice Age changed. And every time it would pull back, the stuff that was left behind that it had been carrying would just be left in big piles. So here you can see all these piles of sand that form these dunes. There's actually an ancient beach about 5,500 years old that used to be where Lake Michigan stopped. And then as it pulled back and sort of the level of the lake went down, this sand was left behind. These layers of stuff left behind from glaciers are called moraines. And you can trace how old the glacier is and how quickly the glacier melted and moved and how quickly it became a lake by looking at layers of sediment in the moraines and analyzing the chemistry of the little sediments of rock that are left behind.
Over the past 10 to 15,000 years, our landscape has been heavily influenced by glaciers, these giant frozen rivers of ice that can flatten everything in their path, and then when they melt, create tons of rivers and waterfalls and things that can shake the landscape through weathering and erosion and deposition of sediments in new places. Almost all of our rivers and the way our land is shaped is really a credit to the glaciers of the Ice Age. So I wanted to show you how they work. I've made here a map of Indiana of sorts out of aluminum foil. When I think about the geologic processes of Earth, things like earthquakes and plate tectonics and volcanoes, I imagine it having kind of an unpredictable effect on the land around me. So I'm going to crumple this up into a really nice ball and then carefully unravel it so that I don't break anything here in our landscape. Well, I've got my map again, but it's got a lot of crinkles in it. These crinkles represent hills, which we have a lot of in southern Indiana, but if I recall correctly, where we are is pretty flat. That's because the glaciers that kind of moved south during the Ice Age didn't get all the way through Indiana, carving rivers like the ones you see here in hills, and so they stopped about 2/3 of the way through the state. To represent these glaciers, I am going to use an ice cube. Just like the ice cube has kind of a flat side, the glaciers flattened the top part of the state. If you're trying this at home, all you have to do is take a glacier and use it to flatten the foil as much as you can. Don't worry about the fact that the ice cube is probably going to melt in your hand while you do this, because we're actually going to use that as part of our model. Now, we're only going to flatten the northern part of the state because the northern areas of our planet during the Ice Age were the ones covered in glaciers, as well as tops of mountains that got really cold. But as the glaciers started to move further and further south, as the Earth started to warm up again, the glaciers would melt and then would retreat or move back towards the north, where the glaciers are now. Arctic areas, Canada, Alaska, Russia. So we only really got to flatten part of our state before all of the ice started to melt. And once the ice started to melt, it found pathways in between the hills and the valleys and started to form rivers and waterfalls, carving out the really hilly landscape in southern Indiana that I've shown you a lot of my videos. So only the northern part of the state got flattened, and glaciers carved out the southern half afterwards. Let's take a look at our state now. The northern half has this nice flatness to it, while the southern half is really crinkly. This is what the glaciers did to our state, as well as many other states in the Midwest, Illinois, Ohio, even to some extent Kentucky, Michigan. They flattened the north and melted and carved out the hills in the south.